what is a physical quantity. So which is called as a physical quantity. Anything which can be measured, it is called as what? Physical quantity. So in physical quantities, some are required only magnitude and some are required both magnitude and direction. Okay, so those physical quantities which requires only magnitude, then we call it as what? We call it as the scalars. And there are the quantities which have both direction and magnitude, and they are called as what? Vectors. Okay, so as we know, scalars are the simple things which we can add or subtract or multiply like a normal algebra, but in case of vectors it is not like that. If the direction changes, the resultant of addition or subtraction or multiplication may changes. Okay, so that is why we have to spend more time on the what? Vectors. So that is why we are separating vectors from your motion in a plane. Okay, so that is what. So we have just started with the vectors in last class, but we are not studying it, not starting properly. So from this class, so we have to go with what? Vectors. Okay, so without wasting time, so vectors. So as you already know, vectors is what? It is a physical quantity. It is a physical quantity which has both magnitude and direction as well. Okay, so this is having magnitude and direction as well. Okay, so if you take any physical quantity, if it is having both direction and magnitude, then it is called as what? Then it is called as the what is this? Vectors. Okay, so what do you mean by exactly magnitude? It is what? The amount of quantity. Direction means in which direction it is going. For example, we have already discussed. So if you take the velocity, or you can take acceleration, or you can take force. Okay, so these all are what? These all are the vectors. Okay, so without the direction we cannot understand, or our answer is not going to be complete. Okay, so suppose if I take the velocity as the vector, so how what the both magnitude and direction will give you. Suppose if I say a vehicle is moving, vehicle is moving with velocity say some 80 km per hour towards what? Towards say Bangalore. Okay, so a vehicle is moving with a velocity 80 km per hour towards Bangalore. Okay, so velocity is what? Velocity is a vector. Okay, so if you want to tell this is a vector, what is required? You require magnitude. Then what is the magnitude here? This 80 km per hour. This 80 km per hour is going to be what? Is going to be magnitude. Okay, if you simply say it is moving with 80 km per hour, there is no meaning. In which direction it is moving, that is also important. So towards Bangalore. So this is what? Towards Bangalore. So this is what? This is giving you what? This is giving you direction. Okay, so that is why. So this velocity is having both magnitude and direction. So you can call it as what? You can call it as vectors. Okay, I hope you understood what exactly vectors are. Okay, so how we can represent the vectors? So how we can represent the vector? Representation of vectors. So vectors can be represented mathematically and graphically as well. So first we will go with the mathematical representation. Okay, so mathematical representation. Okay, so mathematical representation. So what will happen in mathematical representation? Suppose A is a vector. Suppose A is a vector. So how you can represent this? You can represent this as vector A. Okay. So A with a bar. So this is what, how you can read this one? You can read this as vector A. For example, velocity. For example, velocity. So how you can represent? This is what? Vector V or velocity vector. Okay. So vector V. So you can read like this, or velocity vector. Okay. So this is what the mathematical representation of vector. Then this will give you what? This will give you a total vector. Then what about the magnitude? How you can represent the magnitude? So magnitude will be represented as, so magnitude of vector A, magnitude of vector A. You can write it as magnitude of vector A. Okay. So this is what magnitude of vector A. So this will give you what? This will give you the amount of quantity. So this will give you what? Amount of quantity. Okay. So this will be a value, or this will be a number, and it is always what? It is always a positive. It is always a positive. Suppose if I take the same example of here. So which is vector? Velocity vector. So if I take velocity as an example, so vector V will give you what? Velocity vector. Then what about magnitude of this one? Vector V magnitude in this example it is 80. So you can write it as 80. Okay. I hope you are understanding. So vector V is like this. So magnitude of vector is what? It's quantity, amount of value, or it is always going to be what? It is always going to be some numbers. Okay. Suppose you are having acceleration. So if you want to write acceleration in terms of vector, so what you can write? You can write it as vector A. Okay. So magnitude of this vector A, you can write it like this. Okay. Suppose you are having the force F. So this is what? Acceleration. This is what? Acceleration. So suppose if you want to write about the force. So force. If you want to write in terms of vector, so force and F you have to write, then you have to put arrow mark over that one. Okay. So this is what? Force. So magnitude of force is what? This much. Okay. So I hope you are getting what exactly magnitude is and what exactly vector is. Okay. So this is what the mathematical representation, how we can mathematically represent a vector. Okay. So if you want to know what is the graphical representation, so graphical representation, the graphical representation of vector. So how we can graphically represent the vector? Okay. So suppose if somebody asks you to draw the flowing of water, so how you can draw? You can draw like this. So they are flowing in this direction. If somebody asks you to draw the scene of rain falling, so what you can write? You can draw it like this. So these arrow marks, what they are showing? They are showing the direction of flow. Okay. So similarly, so vector also can be represented with a line with a head over here. This is what arrow mark. Okay. So this is what going to be represent your vector. Okay. So this is what vector A. So this will give you what? This length will give you what? This length will give you the magnitude. This length will give you the magnitude. Then what about this one? This arrow mark will give you what? It will give you the direction. Okay. So this will give you the direction. So suppose if I draw over here, this is called as what? This is called as head, and this is called as tail of a vector. Okay. This total is what? This total is called as vector. Okay. So this is what how we can graphically represent a vector. Okay. Suppose if you want to represent say 100 km/h, suppose you are having the vector. So suppose you are having the vector V. So again I will take the same example over here. So that is what 80 kilometer per hour. So velocity is what 80 kilometer per hour. So direction is what towards Bangalore. Maybe take Bangalore in this direction. Okay, so maybe Bangalore is over here. So how we can represent that 80 kilometer per hour on your small board? So what you have to do, you have to make a scale over here. So 80 kilometer. So I will take say 10 kilometer is equals to 1 centimeter. You have to define your scale. 10 kilometer is equals to what? 10 kilometer is equals to 1 centimeter I am taking. Means 80 kilometer means 80 centimeter. So 80 kilometer means 8 centimeter. Okay. 10 kilometer means 1 centimeter. So 80 kilometer means what? 8 centimeter. So you have to draw 8 centimeter. You have to draw this as 8 centimeter. Okay. So this line length should be 8 centimeter. Now you have to show the direction. On which side Bangalore is there? Bangalore is there on this side. So give the direction. Okay. So this is what how we can reduce the big values on your paper, on your board. Okay. So for that, what is required is scale. You have to take make your own scale. Okay. Like plotting the graphs in your x and y axis. Okay. So this is what the vector v. So this is giving you what? This is giving you magnitude. Okay. So this magnitude is what? This is what the magnitude. When they ask the magnitude, you have to convert. When they ask the magnitude, you have to convert. You cannot write 8 centimeters. So you have to write again what? You have to write it as 80 kilometer per hour. Okay. So this is what 88 centimeter per hour, like that. This is what how we can convert your big values to the vectors. Okay. So this is what all per hour is there. Per hour. So no need to worry about all those things. So this is how we can represent the vectors in terms of graphical representation, mathematical representation. So let me draw simple simple vectors. So suppose if I take the directions over here, this is what north and this is south. So over here, this side, what it is, west or east? This is going to be east. This is what going to be west. Okay. So I will draw a vector over here. Say it is of 5 units, 5 meter or 5 centimeter or 5 kilometer, whatever. So that way I am writing units. Okay. So making some 30-degree angle over here. Okay. So how you can what is the meaning of this one? So if you get this diagram, so what is meaning of this one? So this vector you can relate as it is having 3 units in what is the direction? Direction is due north of east. Okay, due north of east. Okay, so this is what direction, due north of east, due north of east. Okay. So similarly, if there is one more vector, say like this, so it is having say some 60 degree over here and say 3 units, 3 or 4 units. Okay. So this is having what? 4 units. So now, so how we can get this one? This vector suggesting that its magnitude is 4 units. So direction is in 60 degree due north of west. Okay, 60 degree. What we can write? So in 30 degree, I have not mentioned over here. Okay, 30 degree. In 30 degree due north of east. So in 60 degree due north of west. Okay, north of west. Here it is north of east. Suppose if something over here, so say 20 degree. So what you can write? It is of say some 5 units, 6 units, so 6 units. So what you can understand? It is 6 units in magnitude in 20 degree due west of south. Okay. due west of south. Okay, so it's a simple example. So when we get some vector, how we can or how we can understand, so what we can get from that one. Okay, so we'll see more examples with this one. Suppose you are going with, say, what you can say, suppose your home is at a displacement of say, instead of taking displacement, if a vehicle is moving with, say, acceleration 10 meter per second square. Okay, so it is moving towards north. Okay, it is moving towards north. So simply how you can, with the help of these directions, if you want to draw this one, how you can draw? You can just make your scale. So 1 meter is equals to what? 1 meter is equals to, you can take it as 1 centimeter. So 10 meter per second will become what? It will become, say, 10 centimeter per second. So you can take this magnitude at 10 centimeter. Direction north. So towards north means your vector will be here. Okay. So like this, simple. It is representation of vector is very simple. So whenever vector is given, we have to understand, so what is magnitude and direction. Okay, so we'll see a few different types of vectors. Simple types we will see. There are so many number of types of vectors are there. So what is required for our study, we will go through those things. So first one, we will talk about something called position vector. Okay, so we'll talk about the position vector. So when the word position comes, we should know that there should be a reference point. Without a reference point or origin, we cannot define, or we cannot take the word called refer, or it is position. Okay. So suppose your origin is here, origin or reference point, origin or reference point, and this is what the extension from the origin. Now where is the what is the position of particle? Position of particle is here. So this is what the position of particle. This is what the position of particle. Okay. So it is, say, P. So I will write as P, and what is the position vector? So this is what at time t equals to, say, you can call it as 0, okay, or time may be 1 second, 2 second, whatever. So for this, what will be the vector? The position vector of particle P at t equals to 0 is this one. This is what going to be a position vector. Okay. So how what you can write? Position vector of P at t equals to 0. Position vector of P at t equals to 0. Okay. So now after some time this will move and come here. Okay. So you can call this as P dash. Now time will become, say, some t. Now what is the position vector? Position vector is from here to here. So you have to take it from here to here. Okay. So from here to here. So how we can take this one? So this is what vector from here to here. This is going to be what? This is going to, actually you cannot draw it here. It should be here only. So this vector, how we can read? So this vector you can read it as position vector of P at t equals to t. At t equals to t. This total is what? Position vector at t equals to t, and this is what? Position vector at t equals to 0. If I draw here separately from origin here, so this is what vector P, and this is what vector P when t equals to t and t equals to 0. Okay. So this is what the position vector. So if you draw it in the with x and y axis, so this is what x and x dash, so y dash. So here this is what going to be a reference point, or this is what going to be a origin. Okay. So at t equals to 0 or some t equals to t1, maybe your position of particle is here. Okay. So P is here, or you can take it as, okay, you can take it as P. So this is going to be what? This is going to be a position vector. Position vector, this you can take it as t equals to t1. Position vector is this one. This is what going to be position vector. So you can represent this as vector P, okay, or you can write as vector R also, no problem. And similarly, at t equals to t2, maybe position may be here somewhere. This may be a position. So this is what going to be position vector. Say now it is q at t equals to t2. So this is what vector q. Okay. So P and Q are what? Position vector of P and Q at t equals to t1 and t equals to t2. So vector P is position vector of P at t equals to what? T equals to t1. Or vector P you can write as position vector of Q at t equals to t2, okay, or you can take p only, no problem. So these are the what? Position vectors. Means how we can define the position vector, okay. So this is a vector, or it is a line joining from or extending from origin to the position of the particle, okay. So how we can define it? A vector extending from, so how we can define this? So definition of position vector. So position vector, so how we can define the vector that extends from origin to what? Position of the particle, to position of particle, okay. So we can write as simply the vector that extends from origin to the position of particle is called position vector. Is called position vector. Remember what exactly position vector is? The vector that extends from origin to the position of particle is called extend from origin to the position of particle. Extend from origin to the position of particle. So that vector is called as what? Position vector. Or simply you can say it's a vector joining origin with the position, or vector extending from origin to the position, or from reference point to the position. Better word is what? Reference point. The vector that extends from reference point to the position of that particle is called as what? Is called as the position vector, okay. So these are the what examples of position vector. So any vector drawn from its origin to the position of that particle is called as what? Position vector. Similarly, like position vector, one more very important, that is what? Displacement vector, okay. So displacement vector, okay. So what exactly the displacement vector is, okay. So how we can represent? Suppose this is the reference point, okay. So there is one particle, say P, okay. So what is the position vector? From here to here it is the position vector, okay. This is what at t equals to 0. At t equals to t dash, this particle will come here. This particle will come to this point, say p dash, okay. So at t equals to t. So now position vector is from here to here, okay. Now position vector is, this is what? Say vector p. So from here to here. So from here to here, total, from this end to that end, from here to here. This is what? Vector p dash, okay. So p and p dash are what? P and p dash are what? Position vectors, okay. So position vectors. What you want to know? You want to know displacement. So very simple. Before it was here, now it is coming to here. What was the displacement? This is what the displacement. This is what the displacement. So if you take this only this vector, that is going to give you what? Displacement vector. So displacement vector. Okay. I hope you are getting. So what is displacement vector here? P dash. So P dash. Vector P dash is the what? Is the displacement vector. Displacement vector. Okay. So the vector that represents the what? Displacement of the particle. Okay, or displacement of the object. Can you get, how can you get P dash? Can you get P dash as vector P dash minus P? Vector P dash minus P. This minus this will give you what? This will give you the displacement. So difference between the position vectors of particle at t equals to 0 or t equals to t and t equals to 0 will give you what? Will give you the displacement vector. Okay. So that is what the displacement vector. Similarly, if I take the same examples over the coordinate system, so x and y axis, this is going to be x dash and y dash. Okay. So suppose at t equals to 0, t equals to t1, this is what the position of particle, say p, and at some time t equals to t, this is the position of particle. So this is what vector p and this is what vector p dash. So what is this one? This is going to be what? Your position vector. Okay. So this is what going to be position vector. So not position, it is going to be what? Displacement vector. Displacement vector. Okay. So this is P dash and P, again P dash minus P, vector P dash minus vector P will give you what? Will give you the P dash. That is what? That is nothing but displacement vector. Displacement vector. These two are what? These two are what? Position vectors. These two are position vectors. Okay. So how we can define this displacement vector? Very simple. The vector that represents the displacement of the particle. Okay. So that is what we call it as the displacement vector. So if you want definition, we can take definition also. So the vector represent the displacement of particle. Displacement of particle is called displacement vector. Is called displacement vector. Okay. So this is what the displacement vector. Two more very important separation of vectors. One is called as polar vector. And another is what? Axial vector. Okay. So not required much. It will be required on later competitive exams, but better if we study. Okay. So what exactly polar vector is? Suppose if you want to draw the displacement vector or position vector of some object here. Okay. So you are having an object over here, and this is what the reference point. So if you want to draw, or if it was here and it come to here, so if you want to draw displacement vector, this is what going to be what your displacement vector. Okay. So it is in the direction of motion only. Okay. So your head and tail are on the same line. Your head and tail of the vector is on the same line. That means the vector which is in the direction of motion. Okay. The vector which is in the direction of motion of object only. Okay. So that is what the polar vector means, a translational effect. The vector due to translation means what? Moving in a straight line. Okay. So the vector due to what? due to translational effect. Okay, translational effect. Okay, so that vector we call it as polar vector. That means suppose a vehicle is moving, say with 60 km per hour. So if you want to draw this velocity vector, so how you can draw? You can draw in this direction only. Okay. If you want to draw it here, so you will draw it here only. This is what the vector v, 60 km per hour in this direction. So your vector is in the direction of motion. Okay, so this vector is called as what? Polar vector. Means both head and tail. Head and tail are on the what? On the same line. Okay. So that is what we call it as the polar vector, the vector which is in the direction of motion, or the vector due to the translational effect. This is a better definition, and you can use this definition also. Then what is the axial vector? Okay, so remember, the vector may not always in the direction of motion. Suppose something is rotating. If something is rotating, vector is not in the direction of rotation. Vector may be along the axis of rotation also. Suppose you are having this screw or something. So if you go on rotating, so what will happen? Your rotation is in this direction. You are applying force in this direction, but your screw is going in what? Your screw is going in upward direction. So this is what the vector. The direction is here, so that is what going to be vector. But force is what? Force is going in this direction. But rotation is here, but it is moving in what? It is moving in upward direction. Or if you rotate in reverse direction, so what will happen? It will go in downward direction. So vectors are going to be either upward or downward, but force is acting what? It is in rotational manner. Okay. So suppose this is the what? Some rotation. If rotation is here, so vector is going to be in this direction. Okay, along the axis. So this is what? Axis of rotation. Axis of rotation. Okay. Here vector was in the direction of motion, but here vector is along the axis of rotation. The vector which is along the axis of rotation, which is along the axis of rotation, or simply we can say the vector due to rotational effect. The vector due to rotational effect is called as what? Is called as axial vector. Okay. Suppose if you take the screw, so suppose if you take the screw, okay. So yeah, as you go on applying the force here, okay, it is rotating in this direction. But in which direction screw is moving? Screw is not moving in this direction. Screw is moving in this direction. So this is what axis of rotation. This is what axis of rotation. This is going to be what? Your axial vector. This is what going to be your axial vector in the direction in which that screw is moving. Okay. So remember, very important. Many times we use the axial vector also. We use the polar vectors also. Okay. So polar vector means the vector due to translational effect. The axial vector means the vector due to rotational effect. Okay. So apart from this, these are the what basic